When thinking of creating your own 3D printed objects, you usually have a concrete idea in mind. In my case, I want to 3D print some labels for the herbs on our balcony. Here one for basil and one for peppermint. I have already checked and noted the desired dimensions with a ruler. The first step is then usually creating the actual 3D model in a 3D or CAD software. CAD for computer-aided design. I typically use Autodesk Fusion 360 for this, which is free for hobbyists or small startups. You usually start with so-called sketches, which are basically drawings on a 2D plane, which are typically extruded into 3D space later on. Here I'm sketching the contours of my envisioned label. This is time-lapsed, by the way. Then I'm extruding parts of that sketch into 3D space by pushing it up 1.5 millimeters. After that, I'm adding the actual label, again as 2D sketch. Which I then extrude up 1 millimeter. Finally, I'm adding so-called fillets in order to round off the edges in the upper part. Then the object is being exported in a format suitable for 3D printing, usually the STL format. As it is now, a 3D printer can't really do anything with a 3D object because devices like these are actually quite stupid. The instructions are generated in a software called a slicer. As the name already reveals, a slicer slices 3D objects into fine layers, which are then being printed by the 3D printer. I'm using Simplify 3D for this. Here you import your 3D objects and tell the 3D printer with a whole lot of different settings how to deal with the objects and how to print them. You can set up things like layer heights. An object can be printed in very fine slices or not so fine slices. The finer, the longer it takes to print the objects. Another important parameter is the infill percentage. A 3D printed object is typically not completely filled with material, but you can fill it completely if you like. Other parameters you usually set are temperatures for the hot end, which is the part in a 3D printer that is heating the plastic material in order to melt it, and for the heated bed on which the material needs to stick while printing. Different materials need different temperatures. When you're finished with all those settings, you can have a preview of how the 3D printer will actually print your objects. If you're satisfied, you export a special file to be utilized by the 3D printer, the so-called Gcode. These are instructions which tell your printer exactly what to do in order to print your objects. You can typically communicate directly with the connected printer or save the Gcode to an SD card, which is then read by your 3D printer. Now the printer is starting to print with a chosen material in form of a so-called filament. These come in different materials and colors. For this print I decided to use a yellow PLA, which is probably the most used 3D printing plastic material. This filament is then transported by an extruder, a gear mechanism, through the hot end, where it is melted at a temperature between 190 and 260 degrees Celsius, depending on the material, and then pressed through the nozzle. Now the objects are being created layer by layer. Typically the print head and the printed bed are moving in several directions while printing. Each and every movement is defined in the Gcode instructions as created in the slicer software. 3D printing objects takes longer than you might think. Those little pieces, although being very thin, took 48 minutes to print. When the heated bed has cooled down, the objects can be lifted very easily. And that's how I created my 3D printed labels for basil and peppermint.